Chapter 8, Selective Master Keying. This is Part 8 of a 17-part series. Let's return to an example from the previous video. In this 3-level master key system, the customer asked for a lock which operates with 2 change keys from different masters, AA4 and AB2. Here's AA4 and there's AB2. We saw that this would be problematic because the keys do not share a 1-pin master. Hence, they differ from each other in more than one place, which means the cross-keyed lock will require master pins in more than one chamber. And putting master pins in more than one chamber causes incidental keys. Here's what happened when we cross-keyed a lock to those keys in yellow. The keys in pink operate the lock, even though they were not intended to do so. This is internal key interchange, and it's unacceptable. This was a proposed alternative. Rekey the A4 lock to AA9, rekey the AB2 lock to AB5. Now they share a row master, they're in the same row, and there will be no incidental keys for that lock. But what if this was just the tip of the iceberg? Suppose the customer comes back and says, "Hey, great job, let's do it again. I want to do it again with AA3 and AA6. We look closer at what's going on. We discover that they gave the AB2 key to the maintenance crew who needed access to the room where AA4 operated, and that's why they're asking for cross-keyed locks. What they really want is a special key that works in some places but not others, almost like a master key unto itself, without causing key interchange. We have such a thing. It's called a selective master key. Let's rewind the clock. Here's what the system looked like before we made any changes. If we knew then what we know now, we could use a selective master key. We might call it ENG, which stands for Engineer's Key. It will be almost identical to the TMK, which is 483165. There are multiple ways to accomplish this. One option is to grab a vertical group master from an unused vertical group. This entire vertical group is empty. We'll use the vertical group master 483765 as our ENG key. It is almost identical to the TMK, differing in only one place. The secret to making this work is that none of the keys in use have a 7 in the 4th position. Only keys in this vertical group have a 7 in the 4th position, which means we need to mark the entire vertical group as unavailable. We sacrifice 25% of the bidding list. We issue the ENG key to the maintenance department. Now the maintenance department needs access to a lock that works with AA4. We rename the lock AA4ENG. How do we force the AA4ENG lock to operate with the ENG key? Easy. The AA4 lock already operates with A, and the ENG only differs from A in one place, the 4th position. We just make sure that the AA4 ENG lock has, in the 4th chamber, pins to work with a 1 cut from A, and a 5 cut from AA4, and a 7 cut from ENG. That's a 1 bottom pin, a 4 master pin, and another 2 master pin on top of that. This increases the number of incidental keys for that lock, but none of them are included in our bidding list. 2 of them are 427765 and 487765, which were in the 4th vertical group, but not anymore. We eliminated the 4th vertical group. The beauty of this plan is it allows us to make the ENG key work or not work with any lock in the system without any key interchange. We can make AA6 ENG, AA3 ENG, AB1 ENG, whatever is required. The downside is that we lost 25% of our system, and we are stacking master pins. 483765 wasn't the only choice. We could have used 483.365 from the third vertical group, or we could have used 481.165 from the fourth horizontal group. But there's another option that doesn't require sacrificing 25% of the bidding list. Look at the KBA. Instead of taking away a progression possibility in a progressed position, let's look at the constant positions. For example, in the fifth position, we have a constant 6. If that were progressed, our progression possibilities would be 8, 0, 2, and 4. We can use one of those 4 values for the ENG key. I pick 2 because it's 4 away from 6, so we'll be using a number 4 master pin. Once again, our ENG key is almost identical to the TMK, differing in only one place. And how do we combine the locks? The ENG version of the AA4 lock gets an extra master pin, but it's not stacked on top of another master pin. Also, we didn't lose 25% of our bidding list. However, one purpose of constants is to prevent one master key system from interfering with another system. By using a 2 in the fifth chamber, this is no longer a constant across the entire system, which slightly increased the risk that this system could clash with another system if the other system has a 2 in the fourth chamber. Once again, we can make this ENG key work or not work with any key on this page. To recap, a selective master key differs from the TMK in just one place, and it is the only key that has that value in that place. Here's an example where every single key in the system is a selective master key, although they aren't really masters in this context. Every one of these keys differs from the master in just one place. This method is very popular in Europe. Any lock can be made to work or not work with any key or arrangement of keys without key interchange. Again, the secret is that every single key differs from the T and K in just one place. The downside to this method is that you can only get a maximum of 20 keys with a 5-chamber lock or 24 with a 6-chamber lock. That's with 2-step progression. With single step, you could get up to 30 keys, which is still not very many. Here is a 16-page 3-level system. Page 1 has change keys under AA. The Grandmaster is A. Page 2 has change keys under AB, which is the page 2 page master. Both AA and AB are under Grandmaster A. There are lots of pages left for future expansion. The left side is the lead sheet, rhymes with bead. The right side is showing page 1. And here is page 2. The customer needs a housekeeping key only for certain doors under AB. How can we accomplish that? One option would be to grab 113824, which is an incidental master key that covers pages 9 through 12. It differs from the TMK in just one place. Specifically, it has a 1 in the first position. Other than that, it's identical to the TMK. We lose 4 pages, but one of those was filled with max violations anyway. But there's another option. It hinges on the fact that we only need HKP to work under AB. We don't need HKP to work for the entire system. On page 2, we can grab the vertical group master from the third vertical group, mark the vertical group as unavailable, and use the vertical group master as our HKP. So now this selective master key only works under AB. It only works on this page. And what happens on the page stays on the page. I picked the third instead of the fourth because the third has more max violations. So we're only losing 12 keys instead of losing 15. Notice that the HKP key here differs from the top master key in 3 places. It seems like we're breaking our rule, but we're sticking to just a page, remember? So what matters is how far away is it from the page master. It differs from the page master in only one place. Right here in the 5th position, HKP has an 8 and the page master has a 2. This is called a limited selective master key. It only works on the page. Next, we'll see another use for selective master keys. With this same 3-level system, suppose that an employee who had a copy of the Grand Master Key A quit on bad terms. You might think, well, that's it. We're done. We need to rekey the whole facility with a whole new master key system. But we have an ace up our sleeve. Remember 113824, that selective master key we grabbed from pages 9 through 12? We can use it as a replacement for the top master key. I suggest we call it B to avoid confusion with the previous top master key A. You might think of it like Grandmaster A is the king and Grandmaster B is the king's little brother, who looks almost exactly like him. He's standing by in case the king dies, ready to step in to the king's place. Here's how we do it. We write a new KBA with 113824 as the TMK, with the exact same progression possibilities with one exception. We've removed the 1 from the KBA. We can't use it because that 1 is in our new TMK. And also we can't use a 5 because 5 was the value for the old TMK in that position. Notice we have lost 25% of our system. But the beauty of this is that we don't need to recut any of our change keys or our master keys AA or AB. All of those keys can stay the same. The only key that has to change is the top master key itself. But we do have to rekey all the locks, or at least we have to rekey the first chamber of each lock. The other chambers won't be affected. The advantage of this is that we don't have to go and find all the people who have the change keys and say, give me back your key, all right, now you have a new key. This is especially valuable if those people are difficult to reach. We could have picked 593824 for B, which is an incidental master key which operates every 4th page. The secret is to find a value in the KBA which has not been used yet for any change keys and which you are willing to sacrifice and never use in any future keys. There are many such values in this KBA. The values in green are the ones that are currently in use. The rest are ripe for picking. We can pick any one of those 7 values from columns E, D, or C. Or if we didn't want to sacrifice 25% of the system, we could pick a value in that constant 6th column. Whatever we pick, we need to remove that value from the KBA and mark out any biddings that contain it. This is the obvious choice, the 4-page master for pages 9 through 12, which I showed you earlier. This would be a very rare request. The customer is asking for a cross-keyed lock that is operated by AB3 and A, but not AB. Can we do it? The usual plan is to make AA, AB, and AC incidental master keys, such as vertical group masters or page masters. One thing we know about incidental master keys is that they happen automatically. You can't stop them. So how could we possibly build a cylinder that works with AB3 and A, but not the master key in between them? We are going to use selective master keys. We grab a value from the KBA to make a selective master key. Instead of calling it ENG, we're going to call it AB. It's the key we want to include or exclude at will. Since we grabbed the 1 from the B column, our page will only have 3 blocks in each vertical group. The missing horizontal group is the horizontal group where the keys contain a 1 in the 3rd position. Those are eliminated because 1 is no longer part of our KBA in the 3rd position. Also notice that I marked the vertical group master of the AB group as do not use. The reason for that is that this is the key that we normally would have used for AB, and we need to make sure that whoever comes along behind us and reads this paperwork understands what's going on. That's why I've added this note to explain that AB is a selective master key, must be intentionally included in each pinning chart. It will not operate automatically. Consider the ordinary AB3 lock. It should operate with AB3 and AB and A. If we combine the cylinder to just AB3 and A, this is what we'd get, which is X1X. If we want it to work with AB3, we have to force it to work by putting an extra master pin in the 3rd chamber. Specifically, our pinning chart must allow for a 1 cut in the 3rd position, because that is the unique cut for our AB selective master. This is a tricky question. It looks easy, but we know it isn't so simple. In a 3-level system, to combine the AB3 cylinder, do you need to know the bidding of the AB key? That's probably the answer they were looking for, but this assumes that AB is an incidental master key. 99 times out of 100, that's how we choose our masters underneath a grandmaster, is that AB would be an incidental master key. But the question didn't say that it is an incidental master key. You could find out whether AB is an incidental master key, and then if the answer is yes, you could ignore its bidding while writing the pinning chart. But how will you know whether it's an incidental master key if you don't know the bidding? This answer is better. If you know the bidding of AB, you can tell if it's an incidental master key or not, and then you know whether it needs to be included in the process of writing the pinning chart. Unfortunately, the person who wrote the test may have overlooked that fact, and if you pick C, they might mark your answer wrong. Here's a better way of phrasing it. Given the following Schlage keys in a 3-level master key system, A, AB, and AB3, in order to combine the AB3 cylinder, you must pay attention to the biddings of... The answer is AB3 and A. You don't need to pay attention to the bidding of AB when pinning the cylinder, because AB is an incidental master key in this situation. We can recognize that it's an incidental master key because every cut on AB is either the same as AB3 or it's the same as A. Here's another way that the question could have been written. After you combine the AB3 cylinder, you discover AB3 key turns, the A key turns, AB doesn't turn. Which of these could explain why the AB key doesn't turn? Well, the correct answer is C. One possibility is that AB is a selective master key. That could explain why the AB key doesn't turn. That's not the only possible reason. Here's another reason. Perhaps the AB key was cut incorrectly. In fact, that's probably more likely than C. I've seen lots of miscut keys. Selective master keys are unusual, and using them in this way is quite rare. One more question. In a master key system, is it possible for a lock to operate with the AB3 change key, the A grandmaster, but not the AB master key? Is it possible? The answer is yes, it's possible if you use a selective master key. Someone who doesn't know very much about master keying but knows a little bit about master keying will probably think the answer is D, it's not possible. But the correct answer is A. And we know this because we are experts in master keying.